Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help you out with problem number 6 here in your homework. And the problem is basically this. We're going to be looking for the centroid of this region, or actually, I'm sorry, the center of mass of this region right here, bound by y equals x squared. That's this function that I've sketched, and y equals x. Now, in most of these problems that we've been looking at, they had uniform densities. This one doesn't. This one gives us a density function equal to 6x, meaning that the density here is 0, and as we move to the right, the density is increasing. Now, it's not clear to me in the problem what the units on that density is. I assume, by the way this is set up, what they mean is in kilograms per square meter. I assume that is a mass per unit area. That means if it's a mass per unit area, that means if you take this and you multiply by some sort of area, which I'll just call dA, you get now a mass in kilograms. So to find the centroid here, weighted by mass, we're going to start by drawing a differential element. I'm going to go ahead and draw a vertical one again. They don't always have to be vertical, but this one is set up pretty nicely for a vertical element. It has a width equal to dx. It has a length equal to this y value, which is equal to x, minus this y value, which is equal to x squared. So there's a length as a function of x as we move left and right. The coordinates of the centroid, so I'm going to put a red dot on the centroid. This distance is just x. This distance is, you'll notice it's bigger than this y value, but less than this one. In fact, it's halfway between them. So the y coordinates, the centroid of that rectangle, is going to be the average of x and x squared. Right? That's this y value plus this y value divided by 2. So that's going to give us, I'll say, y bar for the rectangle. All right. So to find the x coordinate of the centroid, we're going to take the x coordinate for the rectangle. We are going to give it a weight, and we're going to weight it by mass this time by taking our density, which is 6x, and this would have units of kilograms per square meter, and then we're going to multiply by the area of our rectangle, which is going to be x minus x squared. Oops. X minus x squared dx. So our density times our area. This in theory would come out in kilograms. And then we're giving this a weight in kilograms. These then get added up. 0 to 1. I believe is the x value that's going to solve that. Then you have to divide out your total mass, which is going to be, take your density times your area. This product now has units of kilograms, and those will be added up 0 to 1. And that integral will give you x bar. Okay? For y bar, very similar. We're going to take the y coordinate of the centroid of the rectangle, which is equal to this expression. Now we give it a weight, and in this case we're going to be weighting it by mass by taking our density. Again, remember this has units of kilograms per square meter, and we're going to multiply by the area of this rectangle, which would have units of square meters. I'll put the dx over here. So there's our area. That now has this now has units of kilograms. These are added up. Divide out the total mass, which I already wrote an integral for. And there's the setup for calculating the centroid of this cool little sliver region right in here. So I hope that this helps demonstrate how to set these integrals up. Have a great day.